A coronal hole 60 times larger than Earth has appeared on the Sun. Recently, a huge, dark spot known as a coronal hole appeared near the Sun's equator. It is 60 times larger than our planet. The solar wind is emitted from this structure. Astronomers say such a large coronal hole is unusual at this stage of the solar cycle. A coronal hole formed on December 2 near the equator of our star. Within 24 hours it reached a width of about 800,000 kilometers. On December 4, this hole headed directly towards Earth. Therefore, experts expected a powerful geomagnetic storm and aurora borealis. Geomagnetic storms occur when the solar wind, charged particles from the Sun, bombard the Earth's magnetic field, causing it to suddenly change. These types of events are dangerous for electronics due to the increased level of charged particles flowing from the Sun. Geomagnetic storms also affect our planet's atmosphere, changing its density. However, it turned out that the solar wind emitted from the coronal hole was not that intense and the geomagnetic storm was mild. But, for example, the coronal hole that appeared on the Sun in March spewed out the most powerful geomagnetic storm to hit the Earth in over 6 years. Coronal holes are darker, relatively cooler regions in the solar corona. In this temporary region, changes in the Sun's magnetic field occur, allowing the solar wind to escape into space at much greater speeds. The solar wind, a stream of charged protons, electrons and alpha particles, can be divided into two broad categories: fast and slow. The fast solar wind escapes from these holes in the solar atmosphere and can travel at a maximum speed of 800 kilometers per second, twice the maximum speed of the slow solar wind, which is estimated to be around 300 to 500 kilometers per second. Our star goes through activity cycles that last on average 11 years. Our star reached solar minimum, i.e., the time of the least activity during its 11-year cycle, in 2019. During the minimum, another cycle begins, which reaches its peak of activity after about 4 to 5 years. The maximum solar activity for the current cycle is expected in 2025. And the maximum means more sunspots, flares, coronal mass ejections and coronal holes. A huge coronal hole is currently turning away from Earth. It is unclear how long it will remain on the Sun. According to the National Oceanic and Atmospheric Administration, an American institution dealing with, among others, weather forecasting, previous coronal holes in the past lasted longer than one revolution of the Sun, or 27 days. NOAA experts also pointed out that coronal holes can occur at any time during the solar cycle, but are more likely to occur during solar minimum. When they emerge during solar maximum, they are usually located near the Sun's poles, not near the equator. We are currently closer to solar maximum, which is why the formation of such a large coronal hole near the equator puzzles scientists. Recently, there have been many other signs that the Sun is becoming more active. Recently, at least 5 different sunspot groups have been observed on the Sun, and they have emitted dozens of solar storms into space. These spots appeared on November 17 and on November 25. A coronal mass ejection was emitted from a region near the star's equator, a fast-moving cloud of magnetized plasma that later hit Earth and caused spectacular auroras. Another coronal mass ejection was recorded on November 28. The recent increase in solar activity is likely a sign that we are just on the cusp of solar maximum activity. Mycorrhizal fungi can increase yields by up to 40%. Research conducted by Swiss scientists shows that inoculating the soil with mycorrhizal fungi can help reduce the use of plant protection products in agriculture. Moreover, it can significantly increase the amount of crops harvested. In a large-scale field study, yields increased by as much as 40%. Farmlands are full of pathogens that attack plants. This, of course, affects the yield. To combat them, farmers use various plant protection products. But that may change. Scientists from the universities of Zurich and Basel have shown that inoculating soil with mycorrhizal fungi can help maintain or even increase crop yields without the use of additional fertilizers and pesticides. In the researchers' fields, yields after such treatment increased by 40%. The results and description of the research were published in the journal, Nature Microbiology. The intensive use of fertilizers and pesticides in fields reduces biodiversity and pollutes the environment. Therefore, there is great interest in developing sustainable ways to protect plants without the use of chemicals. One example of such an alternative are mycorrhizal fungi. They cohabit with plant roots, and this relationship is believed to be beneficial to both plants and fungi. Mycorrhizal fungi help plants acquire nutrients. Plants repay them with compounds that they cannot produce on their own, such as sugars. The relationship between plants and fungi has been known for a long time. Swiss researchers tested their usefulness in large-scale agriculture. The fungi were mixed with the soil before sowing maize in 800 experimental fields on 54 farms in northern and eastern Switzerland. In 1/4 of the crops, mycorrhizal fungi allowed yields to increase by up to 40%. Higher, says Marcel van der Heijden, soil ecologist at the University of Zurich, co-author of the study. However, in 1/3 of the corn plots, yields did not increase and sometimes even decreased. Initially, scientists did not know why this happened. To find the cause, scientists analyzed a variety of chemical, physical and biological properties of the soil, including the biodiversity of soil microbes. We found that mycorrhizal inoculation of the soil worked best when there were already a lot of fungal pathogens in the soil, says Stephanie Lutz, co-author of the publication. Mycorrhizal fungi act as a kind of protective shield against pathogens in the soil that weaken plants, Lutz points out. Thanks to this, it is possible to maintain a normal yield in fields where without mycorrhizal fungi there would be losses. However, mycorrhizal fungi had only a minor impact on fields not contaminated with pathogens. The plants there are strong and growing well anyway. The use of mycorrhizal fungi in such cases does not bring any additional benefits, says Natascha Bodenhausen from the Research Institute of Organic Agriculture. The aim of the research was to predict the conditions in which mycorrhizal inoculation works. With just a few soil indicators, we were able to predict the success of inoculation in 9 out of 10 fields and thus predict yields even before harvest, says study co-leader Klaus Schlappi from the University of Basel. This predictability allows us to direct the use of mushrooms in fields, says Schlappi. More research is still needed to find the easiest way for the fungus to spread over large areas. Nevertheless, the results of this field trial represent a big step towards more sustainable agriculture, concludes Master.